The quiz today is find the domain of this function. Okay, and people did quite well on this. Then I wrote this down, and I have to apologize. Should have had a negative in front of this 2, a negative in front of this 2. I was thinking about something else, and I didn't notice that what I'd written made no sense. It didn't make any sense. But we'll look at this. And naturally, no penalty if you miss this in the quiz. And then sketch each basic function, show its domain and range, something that I went over fairly thoroughly for at least a couple of the functions in a previous class. So I would have expected that performance on this would have been better than it was. The answer up here, well, 2x minus 8 has to be greater than or equal to 0 because you can't do the square root of a negative, at least not over the real numbers. And this is easily solved. You get 2x greater than or equal to 8, x greater than or equal to 4. So x has to be greater than or equal to 4. And also, x plus 5 can't be 0 because division by 0 can't be defined. So x plus 5 if I could write this in a number of ways, I'll say it's not equal to 0, so that x is not equal to negative 5. You can see that by inspection, but you can always set x plus 5 equal to 0 and solve the equation. So that the domain is, I'll write an interval notation. The domain is actually for infinity, because of course, due to the numerator, due to the restriction from the square root of 2x minus 8, that can't be negative 5 anyway. It has to be at least 4. Okay? If x was negative 5, you wouldn't have this, so you don't include any numbers less than 4. Now, a lot of people did something with that interval, and at this point, I would not regard that as something that would penalize too heavily if you didn't get this, if you did something that involved x can't be negative 5. So if you got this and this, then I'm pretty much happy with the result. Okay. Not going to talk about this because that's been pretty thoroughly covered. I was just seeing if anybody could make sense, if anybody had, or see how many people were able to do this. Also, remember the basic function is just a function as I define it on the set of numbers negative 2, negative 1, negative 1/2, 0, 1/2, 1, and 2. The numbers within that set at which you can express the result exactly. We do that to get a better idea of domain and range. Then you have the extended basic function and the complete basic function. What a lot of people gave on this was the domain and range of the complete basic function. Again, I won't penalize it too heavily if you got all that right, okay? But this is, the meaning of this is strictly what I call the basic function. Okay, so the second problem, this piecewise graph, has a graph that looks like this. Now, why is that? Well, I mean, some places f of x is negative 3. I'll explain it this way. F of x is negative 3 all along this dotted white line, including this orange part, but the orange part is the part that corresponds to the definition. I'll go over that in detail. The x squared function, well, the graph looks like this, the dotted line and then the green curve, okay? And of course, the dotted line could go on past here because they're not just saying the basic function. And then the 1 over x function, which has a graph that looks like this. And of course, there's a part of it over here that looks like this. Okay? The stuff in light white is not part of this graph because the x equals -3 works only for x less than or equal to -2. So here's where x is -2. Here's this part of the domain. The orange arrow here represents this domain, the x-axis. And the corresponding function has value -3 everywhere, so here it is. So this is part of the graph of f of x. The dotted part here isn't. Then between -2 and 1, on the interval from -2 to 1, and I'm going to be consistent, and we say, okay, so here's the interval from -2 to 1. It includes 1. It also includes -2. So -2 is not part of the orange arrow, but it is part of the green segment of the x-axis, the green interval. So for all the x values from here to here, we're going to follow the f of x function, the x squared function. Okay, there it is. And then for all values of x between 1 and 2, but not including 1, we follow the reciprocal function. And it's going to look like this on the interval from 1 to 2. Includes 2, does not include 1. So I can draw the graph and kind of do this and indicate that this point is part of the graph of f of x. This point down here is not. This point is the same for the x squared function as for the 1 over x function. But I've got the green dot there, which is really not totally necessary. But I've got the green dot there just to indicate that at this point, this point is included because it's part of the squaring function. Okay, and the x equals 1 is in the domain of the squaring function. Then the 1 over x function starts just past this point and goes on to this point, and I should definitely indicate by a closed dot that this point is concluded. I will mention some people are confusing open dots and closed dots, and I think I've put comments into the open math homework if you did that. It seems like there's some people who know the difference, they just have the definitions backwards. Because everything they're doing is exactly the opposite, so it should be easy to fix. Okay, well, anyhow, there it is. This graph here jumps up to here, and then goes on to here, and it's nice and continuous here. It continues on without a break. As you go from here to here, all of a sudden, the function jumps up to here with nothing in between. Okay. Those are important characteristics of the function. You want to think about them. But bottom line, right now, be able to sketch a graph of a piecewise function.